Programming is no longer limited by memorizing syntax. Before building useful software, Claude enables beginners to explore code through conversation, turning questions into explanations, examples, and working solutions instead of treating coding as translation between human ideas and machine rules. Learners can focus on reasoning, experimentation, and iteration. That shift makes understanding not typing the primary skill. Most beginners fail before solving meaningful problems because every mistake requires searching documentation, decoding compiler errors, and connecting scattered tutorials. Syntax becomes the obstacle instead of the concept. AI assistance reduces friction, but only when learners ask precise questions rather than expecting perfect code generation. Research also shows modern language models frequently outperform traditional search for explaining compiler errors. RxIV, Claude works best as an interactive teacher instead of an automatic programmer. It can explain unfamiliar functions, simplify algorithms, identify bugs, compare alternative implementations, and introduce programming concepts from first principles. The conversations evolves with every follow-up question, allowing beginners to progressively deepen understanding instead of restarting every search from scratch. Claude 1 results improve dramatically when requests describe the desired outcome instead of vague intentions. Ask Claude to explain each line, identify assumptions, predict outputs before execution, or rewrite code using simpler constructs. Breaking complex requests into sequential tasks produces clearer reasoning, smaller changes, and easier verification than asking for an entire application at once. Claude 1, follow one repeatable loop, read existing code, ask Claude what every section accomplishes, predict behavior, modify one feature, run the program, compare the result with Claude's explanation. Finally, request a review of your reasoning rather than only your code. Every iteration transforms passive reading into active understanding while reinforcing programming fundamentals. One workflow explains unfamiliar code, another isolates bugs by tracing execution and identifying likely failure points. A third generates small utilities such as file, processors, or calculators. The fourth teaches concepts like variables, loops, functions, objects, and recursion using progressively harder examples. Together, they cover the everyday learning cycle of new programmers. Claude Help Center 1. Behind every response is an iterative process. Gather context, analyze available information, perform actions, then verify results before continuing. This agentic workflow encourages learners to think in the same sequence. Effective programmers rarely jump directly to code. They understand the problem, test assumptions, and confirm outcomes before declaring success. Claude generated code is a starting point, not unquestionable truth. Beginners should ask why each solution works, request alternative implementations, inspect edge cases, and run tests before accepting answers. Verification consistently ranks among the highest impact practices recommended for Claude Code because reliable software depends on evidence, not confidence. Claude Help Center 1. As confidence grows, Claude can explore unfamiliar repositories, summarize folder structures, suggest implementation plans, and propose incremental edits instead of overwhelming rewrites. Official workflows encourage understanding the project before modifying it, allowing beginners to transition naturally from isolated exercises to collaborative software development. Claude 1. The long-term advantage is not writing code faster, but learning faster. Beginners who use Claude as an explainer, reviewer, debugger, and reasoning partner develop transferable problem-solving skills alongside programming knowledge. The goal of Lesson 9 is simple: treat AI as a collaborative instructor that accelerates understanding while keeping human curiosity and critical thinking at the center